We are starting on a new section here, and this is scheduling. I've struggled a bit with what to call this, whether to call it tasks or scheduling. It's primarily about how you schedule tasks, so there's the name. And I'm going to talk first about bare metal systems. So sometimes an embedded system is constructed with no operating system. So bare metal means that there's kind of no middle layer between your application and the hardware, in this case the processor. And instead what they use is a super loop. This is one technique anyway. So let's look at a fairly trivial example. So we have tasks, and I'm going to call them T1, T2, and T3. So these tasks are plain old functions, and we're just going to invoke them in an order. I'm going to try and squeeze two things side by side here. We've got our main. So I'm going to use this kind of diagram to show the flow of applications. So this is T1 will be executed, and let's just assume it's returns void. And once it returns, we're going to call T2. And say that T1 you want it to execute frequently, so maybe it's checking the user interface to see if the user has entered a new command. And then let's just say that task 3 runs now, and then we go back to task 1, and then finally let's say task 2 runs again, and this is our whole super loop. And just to add this, the main with the underscore there, this represents our entry point. Okay, so this would be pretty easy to code and see. Let's just do that quickly. Actually, I'll do that in green as well. So int main void, and it's an infinite loop, so while true, and we're just going to invoke those functions in the order that I've shown there. So task 1, task 2, task 1, task 3, task 1, task 2. And close off the main. Now in a real application you'd probably have some setup code that you would run before you entered your super loop. The relative frequency would be the frequency of task 1 is equal to, it runs 3 times for every 2 times that task 2 runs, and it runs 3 times as often as task 3. And you can look at problem set 3 question 1 where you're asked to implement this. It's pretty straightforward. Now what's the pros and cons to this? So on the positive side, it's simple to code. If you're able to do all that you want to do, it's pretty efficient. You're not wasting a lot of CPU time managing things. But one drawback I would say is that it can't respond quickly to asynchronous events. So if somebody presses an input button or something else happens, you have to wait till you actually run T1 to do that, and T2 or T3 might be running away and taking a while. So a problem here is that it can't respond quickly to asynchronous events. And back in the I/O section, we talked about asynchronous events, and we handle those with interrupt service routines.